All right, so in the last class, I gave you the work of configuring voice lanes, or you can say LANs. And these were the commands that I have told you. We can go through them, right? And now, today we're going to use, or we're going to go to switching protocols. Switching protocols is today's topic. I mean, protocols based on VLANs, okay? So the first protocol we do have is Vtp. Vtp stands for VLAN Trunking Protocol. VLAN Trunking Protocol. So VTP in short is basically a VLAN trunking protocol. I told you what a trunk port is, right? When and where we are going to use trunking, you know it. Now it's a protocol based on that trunking, how a trunking should work, and a protocol has been given to you while using switches and you while creating the VLANs, and you transfer the traffic of VLANs from one switch to another through the trunk ports. So based on those trunk ports, a protocol has been given, which is VTP, which stands for VLAN Trunking Protocol, okay? So the first thing about it is it's a Cisco proprietary, it's a Cisco proprietary protocol, P-R-I-E-T-A-R-Y, proprietary protocol used by Cisco switches to exchange VLAN information. So especially this VTP is used by Cisco switches to exchange VLAN information through the trunks, through the trunk ports. So this is one thing about it. Second is, with VTP, you can synchronize VLAN information like as or such as VLAN ID or VLAN name. With switches. Inside the same VTP domain, with the same VTP domain. So it's going to help the switches to synchronize VLAN information with switches, those switches which are inside the same domain, or you can say which are inside the same particular local area network, okay? Another point of it is, I'm going through the basic overview. So a VTP domain is a set of trunked switches with the matching VTP settings. That means what should be the matching one? It's same like as like we have the EIGRP, the same number of autonomous numbers should be there. If it's OSPF, we should be having the area, a different area, I mean same number of area, then only they can share the information. And here we are using this protocol in switching to exchange the information. Over there, it was exchanging the IP address, the routing tables. Over here, in switching, the VTP protocol is exchanging the VLAN information. And what is the VLAN information? Like VLAN ID and VLAN name. But it's also a domain which is going to set trunket switches with the matching VTP settings. The settings can be the domain name, password, VTP version. After that, another point is all switches inside the same VTP domain share their VLAN information with each other. So to better understand the true information or true value of VTP, we will take an example. For example, with the help of an example, I'm going to try to make you understand. Consider an example of a network with 100 switches, SWITCH switches. So without VTP, if you wanted to create a VLAN on each switch, you would have to manually enter VLAN configuration commands on every switch, right? Like we did in our previous topology. Even if you created the VLANs, we entered the commands manually on each particular switch, VLAN ID this, VLAN name this, VLAN. So if you are having 100 switches, that means you will create 100 VLANs, or it can be 200 VLANs on each switch. There can be 2 VLANs. So you have to go one by one and configure the VLAN. So it will take a lot of time for you to configure those VLAN names and VLAN IDs, right? And give access to the ports. Am I correct?
Yes.
So what will happen to just overcome this problem? What we have to do is VTP is going to enable you to create the VLAN only on a single switch. So VTP will help us to create, instead of creating VLANs in 100 switches one by one, like we did in my previous topology. If there were 100 switches, so we used to create VLAN in each particular switch, and if it's 100, then we will create and we have to access every switch. So that becomes a very complex process and very time consuming process. So to overcome this issue and to make the things more easy for us, VTP will help us to create the VLANs or create VLANs. Simply the VLANs does not suit. To create VLANs only on a single switch. Single switch SWITCH. And that switch can then propagate. What's the another synonym of propagate? A simple word. That switch can share the VLAN information to other switches. So it will just not only increase the time, it's not going to only decrease the time, but it will also help us to share the data among other switches. And it's basically a central switch which we are going to use, and it's going to help us to secure the network also. And most of the time, and you can say the very important advantage of this is that we are taking only one particular switch in consideration, and that we are going to handle only one switch instead of handling 100 switches. Are you understanding? We are just using one switch, creating VLANs and giving access to another particular switches and sharing the VLAN informations. You understanding? So that switch can propagate information about the VLAN to every other switch in the same network on the network and cause other switches SWITCHs to create the same VLANs automatically. So you do not have to create VLANs on each switch. We will take one switch, we will enable the VTP over there, and also then when we create, this VLAN on that switch, automatically it will allow other switches to create the same VLAN. Are you understanding? So that's the main important use of VTP, VLAN trunking protocol. So we are choosing one switch, we are creating a VLAN, automatically it gets created into another switch. If there are 100 switches, that means one switch will be taken and another 99 switches will be just used, will propagate the information, and another switches will automatically create the VLANs with the same IDs, with the same numbers. And likewise, if you wanted to delete a VLAN, you will only need to delete it from that particular switch. Are you understanding? So even if you have to create, you need to have that only single switch. Even if you have to delete, you need to delete it from that switch, and automatically it will propagate that particular update to other switches, to other 99 switches in your network, and automatically from all the 99 switches, that particular VLAN will be removed. Are you understanding?
Yes.
So it's just an example of this. If you have a switch like this, I'm taking an example of just 1, 2, 3, 4, 5, and 6 switches. They're all linked by trunk ports. Now, before in my previous example, I told you S1, 2, 3, 4. I used to create VLANs in each switch. For example, VLAN 5, 6, 5, 4, 3, 2, 4, 1, whatever the VLANs are. But it was time consuming, even if you have to delete or if you have to update something tomorrow. So we have to access these switches one by one and then try to modify and update. So what I'm going to do is I will choose this switch S1. I will choose it as a VTP server, and others are VTP clients. I'm going to tell you about it later on. But this is the example. I will create all the VLANs here and enable VTP. With the help of VTP, when you create VLANs over here, like 5, 10, 20 VLAN IDs, name is different. So it will automatically propagate. It will automatically share that VLAN or share those VLANs to all the other switches. And even if you have to remove any VLANs, for example, you created VLAN 10 and you have shared, every particular switch in the network is having the information about this VLAN 10. But when you delete it from here, automatically this switch will propagate it in the switches which are in the same domain, and it will be automatically deleted in the other particular switches. You understanding?
Yes.
But you need to remember one thing: VTP does not advertise information about which switch ports are assigned to which VLAN. Okay, so like if we have 5 PCs on each switch or 6 PCs, that information will not be shared. For example, I have 5 PCs. This information is not shared. How many ports are assigned? That's what I'm telling you. It's not going to advertise about which switch ports, 1, 2, are assigned to which VLAN. For example, this can be assigned to VLAN 5, this can be assigned to VLAN 6, this can be assigned to 7, this can be assigned to 5. So it's not going to propagate that information. It will only propagate the information of VLAN number and name of the VLAN. These are the two things that it's going to propagate. Okay, clear?
Yeah.
Next thing, three versions of VTP are available. V1, V2, V3. The first two versions are similar, except that version 2, V2, adds support for token ring VLANs. V3, in comparison to V1 and V2, adds the following features. In V3, we have, first thing, we have enhanced authentication. Enhanced authentication. This is the feature which is added to VTP version 3. Support for extended VLANs. Extended VLANs are going to start from the serial number 1006 to 4094. VTP version 1 and 2 can propagate only VLANs from 1 to 1005, not more than that. Okay, this is for VLAN version 3. It's going to support for extended VLANs. That means the serial number will be more than 1 to 1006, 5, sorry. And then support for private VLAN. It's going to have the support for private VLAN. Private VLAN. VTP primary server and VTP secondary servers are there. This is something like designated router and backup designated router. So VTP primary server and VTP secondary server. If one switch is down, second will come into existence and provide the services to another switches. You understanding?
Yes.
VTP mode off, that disables VTP. All right, it's going to have the feature. If you want to disable that, you can use mode off. So backward compatibility is there. Compatibility for V1 and V2. The ability to be configured on a peer port basis, that's not a feature. So these are the most important features of VTP version 3. There's version 3, enhanced authentication is there. It's going to support extended VLANs. And it's going to have the support for private VLANs, and it's going to have the support for primary server and secondary servers. And it's going to have the mode, which is VTP turn off mode. That's going to disable VTP completely from the switch. All right, and it's backward compatible. All right, and now let's talk about VTP modes. And then we'll move to the configuration part. So VTP modes, which is very important. These theoretical concepts are very important. Without them, you won't be able to understand what's happening in the switched network. So each switch can use one of the 4 different different VTP modes. One is VTP Client Mode. Second is VTP Server Mode. Third is VTP Transparent. I'm gonna make you understand what is this all about. And VTP Mode Off. All right. So 1, 2, 3, these are the 4 modes that VTP is having. Now I'm going to explain to you all these modes one by one. First of all is VTP Client Mode. What do you mean by VTP Client Mode? A switch using this mode cannot change its VLAN configuration. Remember this thing. If a switch is using VTP Client Mode, it can never change the VLAN configuration. And this means that VTP client switch cannot create or delete VLANs. However, it can just only receive VTP updates, and it can process them and it can forward them. So you need to remember only those switches which you are going to put in VTP client mode, they will only be able to receive updates of VLANs which are created by, you can say, server mode, or which are created by other switch, and that switch we have used, or we have kept that in server mode. So VTP client mode is just going to receive and forward and process the VLANs from one switch to another. Are you understanding?
Yeah.
Then server mode is the main particular switch where we create. A switch using this mode can create VLANs, create and delete VLANs. But here can forward and process. That's it. It cannot create and delete VLANs. It will just receive. All right. So a VTP server switch will propagate VLAN changes. This is the default mode for Cisco switches. By default, the default DEFA or EULT default mode of Cisco switches. By default, every switch is in VTP server mode by default. When you purchase a switch, all switches are in VTP server mode, where you can create VLANs, you can delete VLANs, you can propagate them. So the default mode of Cisco switches is VTP server mode. Okay?
Okay.
Clear? Then about transparent. What do you mean by transparent? Any information about it?
It only sends the information. It doesn't save anything.
Yeah, so a switch a switch which is using this mode does not share its VLAN database. It's not going to share its VLAN database. As I've told you, when you create VLANs on one particular switch, it will propagate that, and another switch will receive, and it will have a database. Like VTP client will have the database, but it will just forward and process it. But if a switch is in transparent mode, it does not share its VLAN database, but it forwards received VTP advertisements. You understanding? So first thing is, it does not, DOES does not share its VLAN database. It forwards, but there's one important thing, it forwards received VTP advertisements. Also, main important thing is you can create and delete VLANs on a VTP transparent switch, but these changes will not be sent to other switches. You can create and delete VLANs on this mode, but like server mode, which is going to help you to forward or share the VLANs to other switches, in this mode, in transparent mode, the switch will be idle. Even if you create VLANs, you will not be able to share them. So, but these changes will not be sent to other switches. Got it?
Okay.
Then off mode, similar to VTP transparent mode, with the difference that a switch using this mode will not forward received VTP updates. So this command is supported only in VTP version 3. All right. So it's similar to transparent mode, but
Hi, stupid.
Who's this? Islam is similar to VTP transparent mode, with the difference there is only one difference, that a switch using this mode will not forward received updates. For example, you got an update from VTP server mode switch, you will not be able to process it. You will just use it, you will just store it in your own database, that's it. You will not be able to forward it to another switch. Are you understanding?
Yes.
Will not be able to forward received VTP updates. So these are the 4 or 5 modes. VTP client, you can forward and process, you cannot create VLANs over here. In server, you can do whatever you want. The default mode of Cisco switches is this, transparent. You cannot share its VLAN database. You can, it forwards received VTP advertisements only. Whatever the advertisements you have received from other switches, you will forward, but you will be able to create VLANs and delete VLANs in this, but you will not be able to propagate those VLANs in other switches. VTP mode is same like as transparent, but it will not be able to forward received VTP updates. Okay. So
Okay.
all switches are configured as VTP servers by default. This is fine in smaller networks without too many VLANs and VLAN changes, since all VLAN information can easily be stored in each switch's NVRAM. However, if you talk about larger networks, it's recommended to specify a couple of high quality switches to serve as VTP servers. If you have a very small network, you got 2 or 3 or 4 switches from Cisco, okay, that's enough. But you know, you can have a similar configuration switches because it's a very small network. But if you're talking about a very big, you know, corporate network, over there you have to have these switches which you use for server mode. If you have the switches, if you have a very big network, the switches that you use for server mode, they should be more powerful than the switches that you use in client mode or transparent mode or VTP mode, because they are just like the servers. They're just like the, you know, virtual LAN servers where we are going to create, which is going to have simply more pressure. It should be having more processing power. It should be having more, you know, RAM. It should be having, everything should be, and of course, it will be more costly than the other switches. Are you understanding?
Yes.
Because the main server switch, the main, you know, VLANs where we can create them, propagate them, it's going to have always more pressure because it acts as a centralized database switch where everything happens and comes in, all right? So always you have to have a powerful switch if you use it as a VTP server mode. Got it?
Yes.
If you use 1 or 2 switches for server, as I've told you, there is secondary and primary servers mode, you can go through it. But another switches, there is no need to purchase, or there's no need to have the costly switches, because we are using them in client mode only most of the time, or even transparent mode or VTP off mode. It's up to you how you're going to use that. Okay.
Okay.
Now let's go and start with VTP configuration. Do you have any question based on theoretical concepts?
No.
Okay, so I will clear them for you. Let me just take the attendance. Print screen. So VTP configuration, we have already learned, or I have already taught you that using STP makes it possible to make configuration changes from 1 or more switches and have those changes automatically propagated to all the other switches in the same VTP domain, in the same VTP network. So in a typical network, Some switches are configured as VTP servers and other switches are configured as VTP clients. So a VLAN created on a VTP server switch is automatically advertised to all switches inside the same VTP domain. So with VTP1 and VTP2, it's not possible to completely disable VTP on Cisco switches, but the best way you can do is to place the switch in the VTP transparent mode. But in VTP3, it has got one added advantage, which is the fourth mode, which I have told you, VTP off mode, which effectively disables VTP. So this article describes the configuration. So in this particular article, I'm going to just describe the configuration of virtual, or you can say VTP version 1 and version 2. Even you can use version 3. So wait a sec. To exchange VTP messages, if you have to exchange the VTP message from one switch to another, 5 requirements must be met. First is a switch has to be configured as either a VTP server or VTP client. So either VTP server or VTP client. This is the first point in order to send the messages. Second is the VTP domain name has to be same on both the switches. When you name a domain, so VTP domain on all switches, if there are more than 2, 3, so VTP domain name, it's a command. When you use the VTP, you have to give the domain name, has to be same on all switches. Third is, if present, the VTP domain password has to be the same. If you are setting up a password, password should be also same. Password has to be same. Also, VTP version, if you're using version 3, that means you have to use version 3 for every particular switch. So have to match. Then the link between the switches has to be trunk link. So trunk link. So as you know, so trunk link should be there. That's it. So let's go and try to configure the VLAN network. Wait a sec. We have just 5 minutes of time. So this was the basic overview of, VTP. I'm gonna stop this meeting here. I'm gonna start again. Please join in again with the same link, okay?
Okay.
All right, just in a second. I'm just ending it here. Let me